Hello everyone, and welcome to another Leetcode video. Today we're looking at the problem 0 Array Transformation 3, which was question 3 in Biweekly Contest 144. I just want to start out by saying that this problem should 100% be a hard problem. It was extremely challenging during the contest. Only about 600 people solved it. I did not solve it during the contest. I had to work on it afterwards to kind of figure out the approach. So if you didn't get it, don't feel bad. This is why we practice to get better at these types of things. But I just want to walk through my approach that I eventually kind of figured out, and just hopefully it helps you and makes sense. So we're given an array nums of length n, and we're given a 2D array queries where queries I represents LIRI. So each query is a range. Each query represents the following actions on nums. So we can decrement the value at each index in the query by at most 1. So this means that we can essentially pick an index in that range, any index, and we can decrement it by 0 or decrement it by 1. And then the amount which the value is decremented can be chosen independently. So we don't have to decrement them all by the same amount. We could choose some indices to be 1, some to be 0, and we want to be able to make an array where all the elements are equal to 0. So the interesting thing about this problem is that we want to return the maximum number of elements that can be removed from the queries, right? So essentially what we want to do here is find the minimum number of queries that we can use in order to make all of our elements equal to 0. With the example 202 as our nums and our queries being 020211, our output is 1. And that's because we can actually remove one query, this 1 query. And why can we do this? Well, if we use queries 0, this goes from 0 to 2, so we can decrement this by 1 and also this by 1, so we'd end up with 101. Then we can also use the second query to do the same thing, so this becomes 000. So this third query essentially becomes useless because 1, which is what this range covers, is already a 0, so there's no need for us to actually use it. So how can we actually solve this problem? So the way we're going to solve it is with two heaps. This is a pretty unintuitive way to solve it, I would say. I think most people probably use something like binary search, where we could maybe select a point in queries and try to see if the queries up to that point would fulfill, that condition to make them all 0. Maybe try line sweep, but after trying all these things, you'll notice that they don't work. So what we're going to do is use two heaps. So how does two heaps actually help us? Well, first thing we want to do here is we want to sort our queries. In this case, they're already sorted, but a prerequisite for this approach is to make sure that they are sorted by the starts, right? So you'll see that here we have going up by start, so we have 2 zeros and then a 1. If the endpoints were different, say this was a 3, we'd also want to make sure that it was sorted by the end date, which should happen with just a built-in sort, but just something to note as well. So then what do we actually do here? So let's traverse through our nums and start at index 0. So we know that at this point, we have a 2. And what does this tell us? Well, we know that in order for this to become a 0, we have to have at least 2 of these queries that overlap with this element, right? So if this is index 0, we have to have at least 2 queries that have 0 in its range. And you'll see here we do. We have 2 of these 0-2s. But how does these heaps come into play? So we're at index 0. What we can do is in one heap, we can gather all of our candidates. And for this, let's call it candidates. And this is going to be a max heap. And why do we use a max heap? Well, you'll see in a second. But basically what we're going to do is we're going to take all of the elements that match whatever index we're at. So here we're at 0. We see these ranges start at 0. So we're going to put their endpoints in this heap. So here we'll have 2, 2. So you may be asking, why a max heap? Why are we doing this? So imagine we have something like this. Say this is our point 0, and we have several queries starting here. Say we have 1, 2, 3, 4, 5. Well, we could have one that goes here, 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 right? So if we're trying to cover a specific range, doesn't it always make sense to choose this biggest one, right? Remember, we're trying to use the least amount of queries. So if we have a bunch of queries starting at the same point, but some are bigger than others, we should just use those bigger ones, because this kind of intuition tells us that if we choose the bigger ones, most likely we won't have to use another interval in the future, right? Because this covers more range. So say, for example, we did choose the smallest one. Well, what if later on we had to decrement 2? If we had chosen one of these, it would be done for us already, right? But if we choose these smaller ones, then we have to use another query later on. So really what we're trying to do here is say, for all of the queries starting at a specific point, I want to know which ones are the largest. And using this max heap lets us do that. Essentially what we're saying is, for all the queries that I can use right now, I want to know how large they are or when they end. So that's the intuition for using this max heap. So now we have all the actual candidates that we can use to decrement this. So what we can then is do kind of a simple comparison and say, well, I have two potential candidate queries that I can use to decrement this, and I see that I have two. So this checks out, right? I can do this. So I can change this to 0. Perfect. So do we remove these? Well, this is where our other heap comes in. We say we're going to have our chosen, which will be a min heap. And remember, the candidates is just the ones that we potentially can use. Our chosen is the ones that we're actually going to use to do this operation. So what does this mean? Our chosen, we have to make sure that this equals whatever element that we're currently looking at, right? It has to be either equal to or greater than that number. And what this means is that I've chosen these two candidates. I've chosen these queries, and I'm going to use these in order to decrement this number. So what I can do is say, okay, I have two candidates, so let me choose one. I'm going to choose this top one, and we're going to put it in here. And then at this point, our heap will just become this. So then I still don't have enough, so I'm going to take this last element, and I'm going to put this again in my chosen heap, right? So now what we're saying is I have two chosen intervals that I'm currently using. I see that this is 2. I can decrement it to 0. So that's kind of the approach here. So why do we choose a min heap? Well, this will come into play later. So say we now move on to 1, right? Well, let's keep this as 0, right? And then we're going to move on to 1 up here. So here we have 0. So let's do a simple comparison. We come here, we've already used these queries, so now we're at index 1. So what we want to do is say, okay, well, here's a new potential candidate that I can use, right? I'm at index 1. This does cover index 1, so let's put it into our candidate heap. So I put the endpoint in. So then what I do is say, well, do I need to use this? Well, no, I don't, because I have these two right here, right? So I don't really need to use this extra interval because I already have 2 covering this space, right? I'm on index 1, but I have these 2 that go up to 2. So in this case, I don't actually need to use this one, so I'm going to leave it there. And then here, this just remains 0. So now I'm going to move on. So now I'm at my final index. So here I've run out of queries, right? There's really no other ones that I can use. I'm at index 2. There are no queries starting at that index, so I don't really do anything here. I don't add anything into my candidates heap. So again, do the same check here. I see that I have 2. I need to make this 0, so I know I need at least 2. So I see that I have 2 in my chosen heap now, so I know that I can do this. So this remains the same, and I can decrement this by 2. But what if we had another number here, right? Well, let's change this and see how this operates. So what if I had this 3? So now I process this, but I see, okay, well, I know that my next index is going to be a 3, right? But the intervals that I'm using, these end at 2. So what I have to do then is say, okay, well, if I go to 3, I know that I can't use these anymore. So I essentially have to empty these out. And this is why we use that min heap, right? We want to track when the next interval ends, right? So if we've chosen an interval, we need to know when it ends, and then we can remove it from our chosen. And what this essentially means is that we now in the future may have to pick more candidates because the number of chosen intervals that we currently have has gone down, right? So that's kind of the intuition for using these two heaps. The candidates is going to just track all the candidates. It's going to be a max heap. And we do this because we want to pick the largest one. So whenever we insert, we're going to make sure that whatever one is the longest is going to be at the top, and we can prioritize that. The min heap will have the other effect of when we get to a certain index, we want to know which intervals we actually can't use anymore. So if, for example, we're at index 3 here, but we know that our range ends at 2, then we can't use these anymore. So we remove them and pop them out. I want to talk about one other kind of interesting edge case for this problem. So let's kind of dry run through this example and see what's different. So again, we're at index 0, right? So we're going to use all our candidates. So what we're going to put into our heap is going to be this 2, this 0, and then this 0. And I got this because we're at index 0. All of these queries start at 0, but I want to record a max heap, so I always know what the largest one is. So here I see that 2 is the longest interval that I have, the longest going from 0 to 2. So then what do I do here? Well, I have 0 here. So do I need to do anything? Well, I really don't need to do anything, right? So I'm not going to take any candidates and choose them, right? There's no point because this is already a 0. So now what I can do is basically just move on. So I'm going to go over to my next. Similar case here, I do have this 1, so I'm going to put that in my candidates. So I'll record that and just update this. So now we have a heap looking kind of like this. But again, I don't have to do anything. This is already a 0. So in this case, I'm just going to, again, move on and not choose anything. So here are where things get a bit interesting. So what do I do here? Well, you see that I have 3. I need to make this a 0. I have no more queries to process, so I have to use what I have here. So I can choose this, right? I could say, I'm going to choose this 2, so that's one that I've chosen. And now let's update our heap. So now our heap is going to look like this. We're going to have 1 up here, 0 here, that should be 0, and then this will be gone. So now what do I do here? Well, I could choose this 1, but wait, can I actually choose this 1? Well, no, I cannot, because I'm currently at 2. I had a candidate previously that ended at 1, but I've passed that point. I can't use this anymore because I've already gone past where this interval ended. So another thing that we have to be careful about is that we might have candidates in our heap that have expired. So in this case, the end date of this previous candidate is actually less than where I'm at now. So in this case, I can't use this, I can't use this, and I can't use this because these have all ended previous to where I am now. So again, you'll see the only actual interval that we have here ends at 2, and we only have 1, but we have to decrement this by 3. So in this case, our 3 is greater than whatever we have in our chosen, our 1, and we know that this is not valid. So we would return -1 in this case. But we also have to be careful about how exactly we are choosing the candidates that we're going to use. So what is the time complexity here? So we are going through our nums array, which is O of n, and for each of these, what operation are we doing? Well, we are going to be inserting elements into our candidates, potentially, which is an O of log n, so times O of log n. And then we're also going to be putting elements into our chosen heap, which is also log n. So overall, we could say this is O of n times 2 of log n, right? But really, what this boils down to is just O of n log n, right? Because we can get rid of the 2 and just say that we can simplify this to O of n for going through our nums, and then an O of log n for actually inserting the elements and retrieving them from our heaps. So let's look at the code and see exactly how this works. So there's a couple things we have to do to actually set up our algorithm here. So the first thing we do is we're going to sort them, because like we said, we want to make sure that these smallest start points are the ones that we can access first. So we're going to sort them by the start point and subsequently also by the end point, just given how the sort algorithm works. This is our chosen query. So this is going to represent the total number of chosen queries that we've done over this entire algorithm. This is different than what we have in our heap, this is going to be basically the total amount that we have ever chosen, whereas our chosen heap will be the ones that are chosen at that particular time. So we have these two heaps, candidates and chosen, which we're going to use in order to keep track of which queries that we're using. Then we're going to have our index, which is the index that we're using for our nums array, as well as our query index, which we're using for queries. So we're going to go through every element in our nums array with this while loop. And what we're going to do is we're going to say, while we still have queries to process, and while our index is greater than or equal to the query's start point. So for example, if we're at index 1, we would want to get all the queries that start with anything from 1 and below, so 0 and 1, for example. And we're just going to push those into our candidates heap. Notice here that I do negative. This is just kind of a Python thing. The heap queue library in Python is implemented as a min heap by default, so kind of a workaround is to put these as negative values and then grab the absolute value later to get the maximum. But don't worry about this. It's just kind of a shortcut to do a max heap. So then we're just going to grab whatever value we have in our nums, and we're going to say, while I have candidates left, and while the length of the chosen that I have is less than this num, I'm going to grab that endpoint, right? That endpoint out of our candidates, which remember is the largest endpoint that we can use. And this is the edge case we talked about previously, where if we've already gone past the point where this query ends, then we can't use it, right? So we're going to check here and make sure that it is a valid endpoint. And if it is, we push it into our chosen heap. And remember, this is a min heap, so we're just going to put in the positive value. And we're going to increment our chosen queries by 1. And this is where we're getting our answer from. We're saying we've chosen a query, we had to use it to satisfy this condition, so let's record it, and we can use this at the end. So then here's the case where we actually don't have enough intervals or queries to actually decrement this number to 0. So if this ever happens, if we don't actually have enough, we'll just return -1 at this point, and we can end our algorithm. So if we get past this point, it means we do have enough. So what we can do is we can set our number to 0. We don't really have to do this. I think it's just nice to kind of, for debugging, just to kind of see which elements have become 0 and which haven't. Then what we're going to do as a final step is we're going to remove any queries that have already ended. So any queries that we've chosen and have ended at this point, we want to remove from our heap. So while our heap is not empty, and while whatever is at the top of the heap is less than or equal to our current index, then we're just going to remove that. Then what we do is we're going to say, increment my index by 1 for my nums, and let's process the next element. Then at the end, we're just going to return the length of our queries minus chosen queries. And remember, the answer we want to return is a number that we can remove. What we've been doing here is finding the minimal amount of ones that we can use to make our array 0, but really what the question is asking for is the number that we can remove. We kind of just have to reverse that logic and say whatever ones we've chosen, we'll just subtract that from the length of our queries, and that will be our answer. So let's submit this and make sure that it works. And it does work. So again, this was a really hard problem, very low acceptance rate. So if you had trouble with it, don't feel bad. I also could not solve it. It was super hard, but I hope that this approach made sense and this was helpful. If you liked the video, please like and subscribe. It really helps. And thank you for watching.